Hello everyone. Welcome back to De La Cruz Engineering Videos. Once again, this is Engineer De La Cruz, and in this video, we'll be solving again a random CE board problem on structural engineering and construction. So specifically, this is all about the structural theory involving the cantilever method and solving frame problems. All right. So without further ado, let's start to solve this problem. Okay, so we have here the situation of a framing plan, a frame of a building that is loaded with a lateral loads. As you can see here, the frame is to be analyzed using the cantilever method. All right. So the questions here is first, this is a situational problem, no? So the first question is to determine the location of the centroid or the plastic centroid of these columns. Okay. For number 2, the axial load for member CF, and for number 3 is the bending moment in member AD. Alright? So first and foremost, ano ba yung concept ng ating cantilever method? Okay? So yung sa cantilever method natin is it is assumed that the axial forces on the columns will be linearly changing, no? Linearly changing, at it will depend sa location ng ating centroid in each either way. Pwede dito sa left side, pwede dito. Kunin natin yung location ng centroid of this column. So generally, yung centroid na yan, dyan mag-a-act yung centroidal forces because of that the column can induce dito, no? Sige, para mas klaro, of course, isolve natin to para mas maintindihan, no? So, how to calculate the location of the centroid? Dito, which of the following most nearly gives the distance of the centroids of the columns from the rightmost members in meters? Alright? Sige, i-move natin. So, centroid of the columns. So, we'll be assuming, no? Suppose ito yung centroid or location ng ating centroid of the columns from the rightmost member. Okay? Rightmost member pala yung hinahanap dito, no? Okay. So, dito sa drawing natin is a location natin here na makukuha is from the leftmost member. So, isa-subtract lang natin to calculate the location from the rightmost. Andito man yung rightmost member natin. Alright? Sige. So, if makukuha natin to, then is-subtract lang natin tong buong length dito, then that is the answer to be calculated. That is the location. So, basically, ang yung hinahanap is yung location nito from the rightmost member. Ayan. Alright? So, hindi ko na lang siya na-include sa drawing natin dito. Okay. So, how to calculate the XG? I will calculate XG na lang. Pwede rin naman doon sa kabila, but sa presentation natin, ito yung na-draw ko. So, calculate na lang natin to, then i-calculate natin yung location niya from the right side by just subtracting the lengths. Okay? Sige. So, how can we do this? Paano natin sisimulan niya? Okay, let's say, tawagin natin tong part 1. Sige. So, yung pag-locate ng centroid ng ating columns is just similar kay Varignon's theorem, by the way, no? Varignon's theorem. So, generally talaga, we should have the areas and the moment of inertia on each column. Dito, dapat may mga areas tayo dyan, cross-sectional area and inertia to solve that. So, sa problem dito, we'll be assuming that the cross-sectional areas of the column are constant because wala siyang binigay dito. And by the way, this problem is a CE board problem, no? Wala siyang binigay na cross-sectional area of the column, so we'll be assuming that they are all constant. Alright? So to calculate the location of the centroid of the column, ang gagamitin natin is the Varignon's theorem. Varignon's theorem. Yan. Parati natin itong nakikita sa ating structural engineering, no? Sa nagsimula sa statics until nag-strength of materials until umabot tayo sa mga major subjects natin sa design. So the Varignon's theorem, we know that if gagawin natin tong reference line, so imagine lang na may mga forces dito acting, no? May mga forces acting on each column. Bale, ika-cut natin to dito. Then may mga acting forces dyan. Right? Sige. Now, using the Varignon's theorem, with refer from the leftmost side, ang gagamitin natin, that would be, basically, ganito siya. The total force, okay? Let's say the total force, Ft, times the xg, yan yung location natin from the reference axis, must be equals to the corresponding moments nila of these forces from the reference axis. So basically, this force here, I will call that as axial force in member AD multiplied by ano yung moment arm ng AD with respect to this reference axis. Of course, that would be 0, no? Plus axial force in member BE, ito, the second force here, multiply natin by ano yung moment arm natin from the reference axis. So, ito yung reference point natin, that would be 6 meters. 6 meters. Okay? Plus, the axial force on member CF times the moment arm. Ano yung moment arm natin from here up to that force? That would be 14 meters. Correct? No, 8 plus 6, that would be 14 meters. Ayan. Ito yung general equation ng ating Varignon's theorem. But to simplify this thing, ito, mga forces yan, yung nilagay natin. Ito, force, this is axial force. Itong this total force is the sum of these forces. This one, and that one. No? So to simplify this thing, take note that we'll be assuming that all of their areas are constant, or basically lahat ng cross-section ng ating column are constant. No? Therefore, maka-cancel out lang natin yung mga forces dyan. Force. Diba? Force is area times stress. No? Area times stress. So, constant yung stress, constant yung area, so maka-cancel out natin yung mga areas natin dyan. I hope that is clear. Therefore, we can simplify this thing. Pwede natin siyang gawin na yung force here, di ba, sinabi ko yung force natin, total force is the sum of all the forces of the column. So, pwede natin gawin na 3, gawin natin numerical na lang, 3, tatlong columns times xg. Correct? Equivalent to 0, that one is 0, ito, automatically that is 0, no? Plus, isang column na BE times 6 meters. Actually, 6 meters na lang diretso. Plus, isang column ng CF times 14 meters. Alright? So, masosolve natin yung xg dito by just dividing this whole term. Ito, copy ko lang. No? Divide natin yan by 3. By 3, and we have here xg. 6.6667 meters. But again, hindi ito yung hinahanap sa problem. As you can see in the choices, may 6.6667 dyan. No? So, yung hinahanap sa problem is from the rightmost member. So, basically, from here to this distance. Okay? From here to here tayo. Klaro? Okay? Yung hahanapin natin is this distance from here to here. I hope that is clear. So that would be 14 meters minus xg. Alright? So, tawagin ko na lang siyang let's say xl na lang. xr, no, from the right. So, that would be 14 meters minus x sub g. And that is the answer. 7.3. Letter D tayo. Okay? So, ganito yung mga tanungan natin sa board exam. Pwede tayong magkamali dito. Lalong-lalo na if hindi natin babasahin ng mabuti yung questions. Okay? So, these tutorials are intended for the board exam takers. No? That is for you to be trained on how to deal with the problem in structural engineering and how to deal with the scam on the choices. Alright? So, for number 2, part 2, which of the following most nearly gives the actual load on member CF? Of course, in kilonewtons. Sige. Paano ba natin isolve yan? Yan. Paano natin isolve? Now, take note, yung mga common solution dito is gagawa tayo ng, di ba, gagawin natin yung ratio and proportion. Basically, pag ito yung gagawin natin, we know that this member will be linearly changing yung forces nila. Ganyan. Ganito man yung ginagawa natin kadalasan, no? At lalong-lalo na sa natutunan natin sa undergrad. Ganito. So, ito yung force niya, ito yung force natin dito, at ito yung force natin dyan. So, we'll be expressing one force to the other force by using ratio and proportion. Alright? But here, I will show you an alternative solution which is for me mas madali. No? Now, analyze this one. If the forces on each column are linear, no? Or we can do the ratio and proportion, then this can be solved using the bending stress formula. Remember that the bending stress formula, kung tatandaan nyo, linearly changing yung stresses. But dito lang, gusto natin gawing forces. So, we can directly solve that. No? We can directly solve the forces in here. Okay, so again, we'll be using the bending stress formula. Okay, para mas makita natin, tawagin nyo itong part 2. Alright. Part 2. So, we'll be using the formula of the bending stress. FB is equals to my over inertia. Yan. Yan yung gagamitin natin. So, you might ask me na, sir, this is a stress. The unit dito is naka MPa, no? Naka PSI, ganyan yung bending stress. But gusto natin kunin yung mga axial forces dyan. So, walang problema. I-multiply lang natin yan ng area. No? I-multiply natin yan ng area. Then, masosolve natin yung force. So, we can actually directly simplify this formula sa force. We can say that let's say, force, F, gawin ko siyang capital, no? That is in force is equals to my pa rin over I. Now, but yung I natin dito is naka-area na lang yung unit. Bale, yung I natin, if you remember, like sa pag-solve natin sa bolt connection, yung may eccentricity, that would be the summation of D squared. Yan yung area natin dito. So, yung D natin dyan is the corresponding distances of the column to the centroid. Yan. So, basically, yung column AD is papunta dyan, column BE is this distance, and column CF is this distance. Ayan. Alright? So, kunin muna natin yung moment. Ano ba yung moment dito sa formula? The moment here should be used, yan yung moment about the neutral axis. So, bali, ito yung magiging neutral axis natin. So, yung moment natin, Remember, yung kukunin natin dito is yung member CF. And in the following question is member AD. Yan. So, one principle or assumption sa cantilever method is that on every midpoints on the member that is assumed to be hinged. Alright? So, para makuha natin yung force on member CF, gawin nating hinge yan. Okay? So, again, in every member on the frame that is assumed to be hinged. So, this is hinge, hinge, and hinge. So, basically, yung distance dito is half ng 3 meters. Midpoint tayo. Okay? So, midpoint tayo dyan. So, ikakat ko siya and I will look the section up doon sa taas. Cut natin siya dito. Ang titingnan ko sa taas. Pwede rin naman dito sa ibaba. But masyadong maraming involved na forces dyan and members. So, pinakamadali dito sa taas. Okay. Cut ko siya dyan and ito yung mangyayari. Bale, ito yung kukunin nating M. So, don't worry. Madali lang to. No? Again, this is 1.5 meters. So, kukunin ko yung M muna dyan. Okay, part 2 tayo dito. I will calculate the M, and actually, as you can see, this is the only force involved here on this section. So, yung moment na yan, that should be 25 times 1.5 meters. Yan lang, napakadali. Ayo, klaro no? Madali lang talaga siya. That would be 25 kilonewtons. Multiply ko siya by 1.5 meters. And that is in kilonewtons meters. That is 37.5 kilonewtons meter. Now, how about the inertia? Yung Y natin walang problema. Yung Y is the distance from the neutral axis to the point of interest. So, yung sa number 2, yung point of interest natin is member CF. So, itong distance na to ang gagamitin natin. Or nakuha na natin to, ito yung X sub R. Alright? Yung I naman, again, I is summation of D squared. So, yung I natin dyan, diretso ko ha, unahin ko tong column AD. So, yung distance ng column AD to the neutral axis, that is the XG. Is it correct? Okay? And take note that yung XG natin is andito. I hope that is clear, no? So, that would be XG squared plus the distance of member BE to the neutral axis. That is, ano tong distance na to? Ayan. That is XG minus 6 meters. Klarong-klaro. And the distance of member CF to the neutral axis, ito yung XR natin. Ito. Diba? Na-solve natin yan kanina. So, idiretso na natin. XG plus, ano tong distance na to? Idiretso ko lang ha. That would be XG minus 6 meters. Then, naka-squared pa rin yan. Plus, distance of CF to the neutral axis, that is our XR, which we calculated dito. Okay? And that is squared. And we have here that value, 98.67 square meters approximately. Again, naka-square meters na yan because this formula, we already multiplied that one to the area. Okay? Sige. Now, to calculate the force on member CF, by the way, lagyan muna natin yung mga forces involved dyan. Okay? If these are pin, then the forces here, this is our assumption, no? This is the actual force in member CF. This is the actual force in member BE. And this is the actual force on member AD. So, yung main purpose natin for number 2 is to calculate the actual force on member CF. And by the way, may mga shear forces din tayo dyan. No? Take note that pag pin yan, dalawang components of force nandyan, dapat may shear force and may axial force. Alright? So, ito yung kukunin muna natin. So, how to, by the way, pala, no? Sa cantilever method, yung unang-una natin na masosolve are the axial forces on the columns. Always yan. Axial forces on the columns. Sa portal method, yung unang-una natin masosolve are yung mga shear forces. Okay? Yan yung tatandaan natin. So far, yung lumabas sa board exam, nakikita ko sa CRF are cantilever method. And meron ding portal method, but commonly cantilever method. Okay? So to calculate the force on member CF, I will just use this formula. Alright? I will just use the MC over I. So the actual force in member CF is equivalent to ito. Okay? So yung F natin dyan, nakadenote na siya actual force on member CF. So we have already the moment. We have the distance of the force in member CF from the neutral axis. So yung distance Y natin dyan is equivalent to XR. Alright? XR from here to here. So that would be XR. Over the inertia which we already calculated. And if we press equals, dapat yung sagot is nandyan. So gawin natin siyang kilonewtons. That is 2.8. So the answer here is letter A. Alright? Gawin natin siyang 3 decimal lang. 2 decimals. Okay. That is 2.8, letter A. Okay. So, to tell you guys, napakadaling solution dito sa cantilever method to use the bending stress formula. Unlike nga, gagawin mo yung ratio and proportion, which is mag-in terms ka pa ng ating forces on each column to the one column para isang unknown lang. No? And pwede ba tayong magkamali sa mga distances? It's up to you pa rin. This is just an idea for you na may alternative solution tayo dyan. Okay? Now, for number 3, which of the following most nearly gives the bending moment on member AD? Alright. So, as you can see, yung member AD natin is andito. So, take note that on each member, constant yung moment dyan. No? Bali, if gagawa tayo ng moment diagram sa member AD, pag ganito lang yan. Ang moment diagram natin is dyan. Because wala namang force. Basically, pag binuo natin tong member na to, walang force na nag-a-act dyan. May shear force, pero walang external force. So, yung moment dyan, moment ng ating DE is constant, meaning, we can solve the moment about at A or moment at D. No? I hope that is clear. So, yung moment na to is equivalent to this shear force VAD times the moment arm distance automatically, which is the moment arm is 1.5 meters. Okay? So, kukunin natin yung ating shear force VDA. Now, in this figure, we cannot solve that directly, as you can see in this figure. Maganda is putulin natin tong member na ito dito sa gitna. Okay? Putulin natin yung member na to dito sa gitna because we know that on each midpoint on the member are assumed to be hinged. Alright. So before that, isolve muna natin yung axial force on member AD. Axial force on member AD muna tayo. Because magagamit natin ito mamaya to calculate the force on shear force on member AD. Alright? Sige, tawagin ko siyang part 3. Okay? To solve the axial force on member AD, so gagawin ko lang is the same formula. Ito, the same formula dito. But of course, yung magbabago dyan is the distance of interest. So, axial force on member AD would be equals to M. Now, ano na yung magiging Y natin dito? Force, take note, force AD yung kukunin natin. So, the distance of AD from the neutral axis, which is equivalent to XG. So, XG over inertia. Ano ito yung force natin dyan? Okay, 2.5 kilonewtons. Okay, now, we can now isolate or make hinge on this midpoint of AB. Gawin natin yung hinge, then tanggalin natin yan. Of course, that would be half ng 6 meters yung distance natin dyan. Then, isolate natin dyan. Alright? So, analyze this figure. Of course, my shear force yan sa member AB and shear force on member, axial force on member AB. So again, yung main objective natin is to calculate the shear force on member AD. So actually, we don't need these values. We just need to know that this must be a hinge, therefore walang moment dyan. So I can solve the value of VAD by just taking moment about this point. Okay, so tawagin ko siyang point O. Hindi ko siya nalagyan ng variable. Let's say that is point O. Ayan. Alright. Sige, let's call that point O. I will say summation of moment about O summation of moment about O naghang pa tayo must be equals to 0. Correct? Okay. So summation of moment about O, VAD will make a clockwise moment about O. Correct? That would be VAD times 1.5. So I will just say na clockwise moment is positive. Pwede rang baliktad, no? Times 1.5 meters. It's up to you ano yung convention nyo. Okay, ano pa yung forces na magpapaikot about point O? That is axial force on member AD, which we already calculated. Axial force on member AD times 3 meters, but that is counterclockwise moment. Iikot tayo dito counterclockwise. So that would be minus axial force in member AD, multiply natin by 3 meters. Okay, now this is will this force 25 kilonewtons will make rotation about point O? No, walang mangyayaring rotation dyan because that is directly to this point. Of course, these two values cannot create moment about that one. Meaning, ito lang yung solution natin dyan. Okay? So, we already calculated the force in member AD. That would be AD. Simplify lang natin konti. Times 3 meters divided by 1.5 meters. Okay? So, that is equals to in kilonewtons. Gawin natin siyang kilonewtons. 5.067. Now, to calculate the bending moment on member AD, so that would be VAD multiplied by 1.5. So, yan na yung magiging moment ng ating column dyan. No? The internal moment. As I have said, constant yung moment natin sa ating members because the loads are only applied at the joints. Okay, so the moment at member AD is equivalent to VAD, which we already calculated. Multiply natin ng moment arm na 1.5 meters. So basically, ito yung moment natin about A. This one and that one. Klaro? That is in kilonewtons meter. 7.6 and that is in letter C. So gawin ko siyang 2 decimal na lang. Is the answer. Okay, that's it. So, pwede nyo ring ma-observe kanina no, na sa figure natin, may force dito sa ibaba, no? At hindi natin na-include sa solution. Well, ma-include natin yung solution na yan if we'll be considering or we'll be focusing on the members dito sa ibaba. Ma-include na siya. So, i-go deep nyo lang. Pinakita ko lang yung idea dito how to use the bending stress formula on cantilever method frames. Alright? So, you can take screenshot sa ating solution. That one, part 1, part 2, and part 3. Okay, that's it. So, I hope you learned from this video and give this a thumbs up. And please, you can also subscribe to my channel if gusto nyo pang makakita ng mga ibang solutions sa CE board. Especially, no? I will just limit my tutorials here solving passboard problem para hindi masyadong mahaba yung mga tutorial problems natin. Alright? So that's it and thank you.